Hi, now that we've done the basics of adding fractions, let's do some algebraic expressions here with some rational expressions. We're going to add them and subtract them, and I put the steps down here for you again so that we can make sure that we use the same steps. The first step is you must have a common denominator to add and subtract. The second thing is we're going to factor the denominators to find the lowest common denominator so that we can see what factors we need. The third step is we're going to use smart ones, which I talked about. And the fourth is we're going to combine our numerators after we find our common denominator, and I call this part is your fractions are in love, and you're just combining your numerators. And then at the very end, we're going to simplify the fractions if possible. Let's start with some examples, and I'm going to go through each one of them, and I hope that you see the cases that we talked about last time. So the first example we're going to do is x over x plus 1 over x squared minus 1. I noticed the denominators aren't the same, so I have to make them the same. So I notice too, this is different than multiplying and dividing. I used to put those in the middle of the board and work up and down. Here you're going to want to work down to do this so you can find a common denominator. So right underneath, I kind of set myself all up so that I can do this. Now, I see x plus 1's here, and I've got two terms. I'm going to put some parentheses around that. And here I see the difference of two squares, so I said, oh, I can factor that. That is x plus 1 times x minus 1. Now, you can lightly cross that off if you'd like. I look at it, these are the two factors. X plus 1 is one of the factors, so this is like one of the cases we did. We could use this entire thing here because that is one of the factors, or as a lot of people say, it goes into it. So I'm going to use this, and I usually leave it in factored form because it's a lot easier at the end if I have to factor to simplify. And the 1's going to stay here because nothing's changing. So that's easy. Now here, my common denominator is going to be x plus 1 times x minus 1. I have x plus 1 as one of the factors. One of the other factors, x minus 1. I don't have that, so we're going to use that as our smart one. So I'm going to put x minus 1, and if you had a quantity divided by itself, it's always 1, and I call it a smart one because we picked one that we needed. I could use 3 over 3, but it wouldn't help me any. Now this is like this. The denominator matches, but the top, I've got to multiply that. So I've got x times x minus 1. Well, you can do it right there if you'd like. Do the distributive property, and so I'm going to do that. So I have x squared minus x. Now, a lot of people right here want to simplify that again and get it back down to where it was. Well, you're going to come back to this, and you don't want it. You want those two to be the same so you can combine them. Here's the part where now your fractions are in love. So I put a big heart through here. And the only thing you combine is your numerators. So I have x squared minus x plus 1 all over x plus 1, x minus 1. Now, when I'm here, I look at this and say, I wonder, can I factor the top? And the top is not factorable. There's no way I can factor that so that anything will cancel, so we're done. There's my fraction. All right, let's try another example. I use some a's and b's this time. Mix it up. Well, I have a fraction here, rational expression subtracted by another rational expression. I have a plus b over a squared minus a minus b minus c over ab minus b. Obviously, they're not common, so I've got to make them common. But before I do that, I have to do the factors to see what to use. So if I factor this, I'm going to use my eyeball. I'm going to take out an a, so I have a minus 1. Here, I use my eyeball again, and I can factor out a b, so I have a minus 1. Now let's set this up. Now, I need to have a common denominator. Well, I need an a, I need an a minus 1, I need a b. The a minus 1's here again, but I don't need to put it down twice. So I'm going to use those three. So my common denominator is ab, a minus 1, ab, a minus 1. If you take your time and go fast slowly, you won't make mistakes like this. You just go through this. Now I look at this. I have this and this. What am I missing? The b. So that's my smart one. b over b. So I have ab plus b squared because I have to use a distributive property, remember, and multiply that through. Here I have the b and I have the a minus 1, but I'm missing an a. So my smart 1 here is a over a, and so I have ab minus ac. Now, here is where I want you to be careful, because I always told you watch for the negative signs. This is correct the way it is, but if I want to combine this, now my fractions are in love, okay, so I want to combine it into one fraction. The denominator is this, but now the numerator, if you look at this, I have a subtraction sign. Well, the subtraction sign goes to this and this, so it's going to change the sign. You have to be really careful when you see subtraction sign. So I have ab plus b squared minus ab, and then minus a negative turns plus ac. So I've combined my numerators, and I notice that the ab's and the ab and the negative ab can cancel out. So I end up getting b squared plus ac all over ab a minus 1. And there's nothing I can factor out of that, so that's my answer. All right, let's try another example. I have x over x plus 3 minus 2 over x minus 1. Again, they're not the same. And I look at these, I can't even factor them, so I'm going to put parentheses around that. That's like one of those cases where you're going to have to multiply them together to get your common denominator. So let's set ourselves up. And our denominator is going to be x plus 3 times x minus 1, x plus 3 times x minus 1. And I'm missing here an x minus 1, so that's my smart 1. And you should show this work like I'm showing you. So that's x squared minus x. And here I'm missing the x plus 3, so that's my smart 1. Now the denominator matches, so I have 2x plus 6. Again, be careful of the negative. All right, that means you've got to distribute that. So now this fraction has a common denominator. It's in love. So we're going to draw a big line. Our denominator is x plus 3 times x minus 1. And I have x squared minus x minus 2x minus 6. Make sure that you carry that through. So I end up with x squared minus 3x minus 6 all over x plus 3 times x minus 1. Now, if you leave the denominator like this, you can check to see if I can factor the numerator, and I can't. It's not factorable, so that's our answer. Let's try one more example, and this is 2 over x squared plus x minus 2 plus 16 over x squared plus 2x minus 3. I need a common denominator. They're not the same. These I can factor, though, so I have x here and an x here, and what I'm going to do is I have factors of 2, so I need to have a plus 2 and a minus 1. Here I have an x and an x, and I have a plus 2 in the middle, so it's going to be a plus 3 and a minus 1. And I double check. All right. Now my common denominator, let's set it up, is going to be, I need an x plus 2, I need an x minus 1, I need an x plus 3, and I have another one of these, so I don't need to use that again. So it's going to be all 3 of those, which makes this look kind of long, but if you take your time and do the steps like this, it will make perfect sense. Okay, now, what am I missing here? Well, I'm missing my x plus 3, so that's my smart 1. So I have 2x plus 6. Here, I'm missing, I got the x plus 3 and the x minus 1. I'm missing the x plus 2, so that's my smart 1. So I have 16x plus 32. Now I have a common denominator. They're in love, so my fractions are in love. I put them together. I have x plus 2, x minus 1, x plus 3 in the denominator. And my numerator, I can combine those, so I have an 18x plus a 38. Now you can factor out a 2 out of there, and if you showed that, that'd be great because I knew you tried to factor it, but it doesn't do anything to cancel, so this is my answer.